Good afternoon, everyone. Um, on behalf of IEEE Computer Society, Bangalore chapter, we welcome you to this webinar. Myself, Vishwas, and Secretary Anand will be with you during the course of this webinar. Just a minute. Yeah. Today's webinar is by Dr. Sameep Mehta. He's associated with IBM, and today's webinar will be focusing on infusing trust in data and AI lifecycle. To introduce Dr. Sameep Mehta, he's a senior technical manager at IBM Research AI. He leads a global team of researchers to build innovative, scalable, and trustworthy AI systems. His recent focus has been to infuse AI in data lifecycle. He received his Ph.D. from the Ohio State University in 2006, and he holds Adjunct Faculty position at IIIT-Delhi. He regularly publishes papers and delivers talks at various academic and industrial forums. So welcome to Dr. Sameep, and I would like to thank you on behalf of IEEE Computer Society for agreeing to be part of this webinar. A warm welcome to you. And Sameep is going to talk about infusing trust in data and AI lifecycle. He will go over data and AI lifecycle and introduce various dimensions of trust. As he said, there has been considerable progress in making AI models explainable, fair, robust, and audible. However, the data component is still lagging behind to adopt those principles. So he will be describing the key results, the OSS toolkits, and also point to some open areas of research that the technical community is driving in this area. So as some of you might know, we've been one of the best chapters in IEEE Bangalore section for the last 3 or 4 years and also recognized globally. And I welcome you to follow us on our website. You can reach us through our email or Instagram, Twitter, Facebook, and LinkedIn. We have all the updates on these webinars and other events through these social media channels. So do follow us, and we'll be very happy to welcome you to the events as well. So without much ado, I hand over the virtual stage to Sameep. So over to you, Sameep. Thank you.
Thank you, Vishwas. Thank you, Anand, for inviting me.
Yeah.
Get
Before we
started.
begin, all the participants, you are muted by default when you join the meeting. Kindly stay muted, and if you have any questions, kindly post them in the chat window. I'll be keeping track of the questions for the speaker, and the speaker will be answering them towards the end of the session. Additionally, uh, if you have any questions toward the end of the session in the Q&A session, you can unmute yourself at that point of time, and you can ask the question. Thank you. Over to you, Sameep.
Right. Thank you. So I hope my screen visible to all.
Yes, it is visible.
All right. Thank you. So, like Anand said, today I'm going to be talking a little bit about governance of data and AI lifecycle. And before I start, all right. So before I start, I think let me put the disclaimer that while I have tried to make this talk as comprehensive as possible, it is very possible that some of the key areas might be missed, and some of these areas do represent the areas of right my and my team's current research interest. So let's move right. So what is the let's start right. Like what do we need to make sure that AI is adopted in a widespread of applications? And one of the critical thing is really the AI solutions, the data, the deployments. They are trustworthy and governed. And we have heard a lot of right, talks about explainability, fairness, how people want their AI models to be fair, explainable, so that they can adopt it without right much concerns and doubts. So this is the kind of key thing in our talk today. We are going to go over what does trust and governance means for the AI lifecycle, what are the key results in these areas, what are the open source toolkits, and where do, at least I believe, right, the research is lagging and we need to spend some more focused time on those areas. All right. All right. So at a very, very, very high level view, right, this is a extremely simple view of data and AI lifecycle. So mostly spread across three major buckets. The first is the data. So this one really looks at, how do we acquire the data, how do we clean the data, how do we make sure the data is ready for any upstream task, be it AI, be it business analytics queries, or anything like that. So that's the first part. Training, I think that's the part we all understand very well. This is where all the magic kind of happens. You take the data, you learn patterns, learn decision boundaries, and really put data to work. And then comes the deployment phase, which is often overlooked, but is very important to really move our models from our labs, from our laptops to in production, right, environment, so that people can start to use it, and there are a lot of associated challenges with it. So this is again the AI lifecycle broken into three parts, and we'll keep coming to this one throughout the talk. Now let's look at the core topic of today, which is to say what are the things which actually make data and AI lifecycle governed. And in my view, we have these three dimensions which makes it governed. So every asset within the pipeline, be it data, be it AI, be it deployment scripts, they need to be trustable, they need to be usable, and they need to be discoverable. If you could do all these three things, then pretty much the whole life cycle is governed and managed well. Okay. So again, just if you in a kind of a mental map, we have three dimensions on which we have divided the AI life cycle, and then we have three dimensions on which we are kind of classifying the governance part of it. And now we'll do a cross section of each and see what it means. So let's start. So let's look at the first cross section, which is to say, okay, what does trustable mean in the context of this life cycle, right? So let's start. So trustable and data life cycle. So what does trustable mean for data? So what it means is that any data we use for our AI applications, it needs to come with proper provenance, proper lineage. So what it means is, right, you need to know where the, right, who collected the data, how did the data come into the data lake, do we have proper consent to use this data, right, and so on and so forth. And I think, right, if you follow news, you will be seeing a lot of these instances where people release a data set and then realize, oops, they didn't take approval from the people who own the data sets or whose photos were in the data set. So I think it's extremely important that we do due diligence in the data acquisition phase, right? Then the data should be fair. I think it should have proper representation from, right, all over the throughout the population. It should be good quality. It's very important because unless the data is good quality, we'll not be able to do anything about it. It should be robust and well sampled, well spread out. Then I think one of the very important area of to look at is that how easy it is to delete one part of the data. So if you look at a lot of the regulatory needs, they give the, like GDPR, they give the kind of a tool in the hand of a customer to go back to companies and say that, I want you to delete my data. So is it even possible to delete partial data, right, for one customer, for two customers, from the whole data lake? And yes, right, in RDBMS sense, right, you might think, okay, right, we will remove few rows. But I think if you really think about data linkages, right, various different data sources, data streaming data, it becomes very difficult. So, this is again, right, one view of what makes data trustable. And again, right, I think don't confuse trust with just fairness and kind of provenance. It's really, the question is that if someone tells you to use the data, would you be comfortable using that data without right? Asking too many questions without being too much concerned. And I think these are some of the questions, if answered properly, people would have that kind of trust in the data, right? Now let's look at training, right? What does trust means in training? So I think like we talked about it, the learning has to be fair. It should not be biased or right, cannot be discriminative towards a group of people. I think that the learning should be explainable. You should be able to explain what you have learned. It should be robust and generalizable. And then just like on the data side, we have the data lineage. It's very important for training side to record all the experiments. I think many times what we do is we record the best experimental result and publish it and show it to people. But I think it's important to record all the experiments because just by analyzing different facets of those experiments, you could learn more things about the model than by just looking at the best result. So, and think about it, right? If someone is were to give you a model and say that this model is 95% accurate, you would most likely not trust it, right? Because there is a lot of other things that you would like to ask, oh, on what data is it 95%? What kind of distributions? Where does it fail? And things like that. And all those things could be answered if someone would have recorded a lot of these things. And then finally, deployed, right? So a deployed model is something which someone has deployed and given an API to you. And what do we need there? We definitely that the deployed model is behaving properly, is not has not started to show some kind of bias. It needs to generate explanations. In the AI world, right, the adversarial attacks are a very, very big problem. So we want to make sure that all our AI model, hosted AI models are do have the guardrails to protect against adversarial attacks. And just contouring on the lineage part, we definitely want to record all the usage of the data, record all the payload data, record all the scoring data, so that this could be analyzed to figure out how the model is doing. So we'll go over details of some of these things in the subsequent slides. And but this is again right. This may not be a complete picture, but I think this covers a whole lot of space on what does trust means for data and AI lifecycle. All right. So let's go a little bit about bias, right? So all of us, right, who have ever trained any model, we understand that to learn any AI model, we need to have discrimination. Discrimination is a decision boundary. So we can't have AI model if the data or the model does not have discrimination. So discrimination is kind of necessary for AI, except when it starts to place certain groups or certain individuals at a systematic advantage or disadvantage. Then it becomes, instead of discriminatory, it becomes unfair. And one of the important thing is that if your data is biased, your model tend to be biased. But even if your data is unbiased, there could be still bias which may creep into the model. That's why we need to handle bias on both sides, on data side as well as I guess someone is speaking. Can please go on mute? All right, thank you. All right, so what do we have? So we have a right. So IBM has released a open source toolkit, AI Fairness 360. It's a comprehensive open source toolkit which with more than 45 different bias detection algorithms, bias mitigation algorithms. So I think the link is here. I think it's a Python library, and now I think it's compatible with R also. There is a interactive web demo which you can play with at aif360.mybluegeeks.net. Right. So just like explainability, just like fairness, explainability is yet another important concept. I think all of us would know what explainability means, but what I'm going to tell you is that there are different versions of explainability. Each one may fit right certain set of users. So for example, right, if you just take a simple example of loan application, the customer whose application gets rejected, his question is going to be, why was my loan application rejected? So now he doesn't care about how the AI model works. He only wants to know about his specific application. So that's what we call local explainability. Then you have a global explainability where, right, someone in the bank may like to say, okay, I want to understand what are different features which contribute to this model behavior. Then you have data explainability to say, oh, why is my data such bad quality? Then many times, we deploy a model in production and it works fine for some time, and suddenly the performance starts to deteriorate. So now the explainability here is really about the model behavior. But why did my accuracy start to deteriorate in last few hours? What exactly changed? And then finally, as a data scientist, one of the important and interesting problem to look at is, can I, just like I feed I take my data and try to learn a model out of it, can I also teach the explanations to my model? Can I input the kind of almost like a right tuple of data and explanation, and then the model learns both the things? Can I do those kind of things? So again, right, just like fairness, we do have a open source toolkit. We call it AI Explainability 360, and it also has a GitHub link and a interactive web demo. I think if you are interested, please feel free to play with it. All right. So the adversarial samples, like we talked about, I think, and many of you would have seen this example, but I'll still go over it. So this is an example where a machine learning model was trained on images of animals, and if you see on your right hand side, it has a image of panda, and it says it's panda with 58% confidence. And what we do is we add this carefully crafted noise to this image. And now what we get is image which is on your right hand side. Now I think, of course, right, to us it looks same. The panda looks panda. However, I think if you look at the same AI model, it now classifies it as a gibbon within almost 100% accurate, right? Confidence, 99.3% confidence. And just so that we know what gibbon looks like, this is what a gibbon looks like. Nowhere closer to what panda looks like, but that's how someone could attack a AI model to deliberately cause it to make a mistake. And these are like not random noises; these are really well-crafted noises, but they are possible to do. So if you go to the links which are there, I think there is a open source toolkit on adversarial robustness toolbox, where a lot of the adversarial attacks and defense techniques are available for everyone to use. All right. The last one I think we are going to talk about, since we saw that lineage runs across all the pillars. We want to talk about lineage. So what is lineage? Lineage, I think, in a very, very simple sense, is how do you track the overall process, which starts from data, goes all the way up to how does the insights get generated from the data, and then how the insights were used. So in the machine learning AI lifecycle, it includes data acquisition, data preparation, how the model was learned, how the model was tuned, final deployment, and then how the model was used in deployment. And and again, right, I think for some of the lineage is very important for, of course, right, for audit and governance point of view. But if you do it nicely, I think it has a lot of other advantages. And the biggest advantage is the root cause analysis. Because now if I have a good lineage system, I could go back, I could see where my model made a mistake, and then I can go back in the lineage graph in some senses to figure out which particular sub module in my life cycle actually caused that error. So while I think the usefulness of lineage is for trust, but I think if you go under the covers, I think you will realize that lineage management is a huge database problem. Because if you have an AI model which is, let's say, used 100,000 times a day, you get at least 100,000 events, at least, right? Because I'm just talking about the usage events, right? Not the feedback data, retraining, redeployment, and all those things. So over time, the lineage data can actually grow very, very, very big. So how do we manage these lineage data is a very, very hard problem. And it requires more than AI. I think it requires your database management skills required. How do we index the data? How do we make sure some of the views are materialized and things like that? So just to give you an example, right, this is a simple lineage graph. It starts all the way from customer data set, produces a model, deploys a model, and then right collects the feedback from the user. And this is like very, very simplistic version. Each of those boxes is actually like 50 or 60 more subnodes in there. So, so I think this is, like I said, right, extremely important and very, very complex data engineering problem to be solved. So, yeah. All right, let's move. So I think, yeah, again, so till this point, I think we really talked about what does trust mean for data, for training, for deployments. And of course, right, we have not covered each bullet item which I showed, but I've covered some of it. So now I think let's move to next part to say, all right, like what does usable means for all these three phases? Okay, so let's look at it. So what does it means for data to be usable? So for data to be usable, it should be good quality, like we said in Trustable, but not all data is going to be good quality when we get it. So how do we improve data quality is one of the big area to make the data usable. How do we enable data sharing, right? Because not every data could be shared with everyone. So how do you make sure that your data, we have enough kind of policies, guardrails around this, so the data could be shared in a governed fashion? And many times, it's not just about sharing the data through some kind of access control list, but it could be more complex because some data could not be even used for certain kind of applications. For example, right nowadays we hear a lot about face recognition. So you could have an image data set. It could be used for other tasks, but it could not be used for face recognition tasks. So how do we build that kind of governance system so that data can be freely shared and be usable while describing to all the policies? So for training, I think, but in the training phase, I think it's the same thing. You want to make sure that just like data sharing, we want to share our models. How do we collect this metadata about models to make it shareable? Can we, if I have, could I build a model catalog which has like 100,000 models, and someone could come in and search for the model which is needed without actually going through all the models and trying to try it out? And it's a very complex problem because right the model metadata itself is a complex problem to figure out, right? Because you have things like network architecture, you have things like parameters, accuracies, metrics, and a lot of these things. But I think this is something which we should be doing so that the models are usable and people don't have to start from scratch all the time. And then just like we talked about uh, the partial data deletion, I think partial unlearning is a kind of a huge problem. So just like I think someone could come and say that, okay, right, please remove my data, but the data has already been used in a model. Now, how do I go back to that model and unlearn some part of the model based on what data is getting deleted? And then finally, I think one of the very, very important areas is around testing. So I think, we have spent decades and decades on software testing, but I think the equivalent of that in the AI world is missing. And I'm going to go over some of the challenges of why is it difficult to do AI testing. And all right, for deployment, I think again, right, the way you make deployment really useful is to really have a very, very rich set of metrics which people could look at. So if you, right, if there are two APIs which are hosted, and one of them actually show you metrics like accuracy, fairness, drift, right, explainability, right, maybe precision, recall, and all those things, and other one only shows you accuracy, it's highly likely that you're going to go with the first one because it shows you more metrics, it's more usable. Right? And then the last point, right, really the triggers for improvement. So for a deployment to be useful, it's very important that it provides some extra information, right? Yes, right, I think it can host a model, but can it also start to now provide me triggers to say that, okay, the model has started to deteriorate. Why don't you look at this data? See if you want to retrain the model. if you want to do some parameter tuning or something. So these are kind of important things for a deployment stage to have to really make it usable. And again, right, I think you will see, right, I mean, overall we come under this theme of governance. So some of these areas are going to be overlapping between discoverable, usable, and trust, which is fine. But what I want to really see, kind of take away is here that how do we make our data training deployment usable from a user point of view? Why would someone like to use, right, our data or our deployment when there are so many other choices? All right, let's go to, I'll go over kind of just in very brief that why do we want to improve the data quality? So again, right, this is a very standard statistics. I think we have looked at it many times that around 80% of time of data scientist is actually spent on data collection, data preparation, cleaning, and so on and so forth. So even though 80% is time spent in data quality, I think overall the the efforts from researchers, right, be in academia, be in industry, is actually only 20% of this area, right? All of us tend to focus more on, right, the learning phase, right? How do we do auto AI? How do we, right, automatically fine tune parameters and things like that? But I think there is a overall gap in this area that, you know, we do not know how to measure the quality of the data. And I'm going to just show you two examples of why, right, this is important. So if you look at this is a very small snippet of one data where what we have learned is we have learned certain profile constraints, some properties of the data. Right? So it says that, okay, if the age is 70, most likely the profession should be retired. Right? A simple intuitive rule which is learned from the data. And now I think when we apply that rule to the other part of the data, we figure out that, you know what, there is a row where the job is retired, but age is 33. Now, this one is a red flag for us because we know, right, when age is 70, most likely the profession should be retired. Now, it's a very simple example, right? But if you think about it, let's say if you're looking at a data set with 1 million rows, and someone tells you that, you know what, this data is not good quality. But that's not actionable. You can't do anything about it. With this simple scheme, what you could do is now you can really focus on that small part of the data, which is actually weak. So I have told you something that, you know, age 33, job retired. I don't think I have seen this kind of sample before. What do you want to do? And right, that gives a very focused and narrow view to data cleaner, maybe data scientist, data acquisition team, to just look at that weak slice of the data and improve it, and not worry about the other part of the data. So that's one way to really look at how do we make data usable in a much more focused fashion. So let's look at another example, right? So this one is really example around homogeneity, right? So for example, many times, you know, in a lot of the data collection mechanisms, the data comes from multiple sources. And eventually someone sits down and puts them, concatenate the data either in a database table or in Excel sheets. And what happens is something like this, that some part of the data, right, represents gender as male, other part of the data is representing as just M, and there could be small m, capital M, and so on, right? Similarly for females. Now, if you have really large data, it's going to be very difficult to find these kind of things because you can't just open that data in Excel and start to scroll. You can't do a select star query and try to scroll. So if there is a easy way for someone to say that, you know what, here are the values which we think are problematic or which need some human intervention, and show it to user just like we are showing it on this screen, right? Where I'm saying that, okay, this is the values I'm seeing, male, M, F, female, F. Can you give me a representative canonical form of these? And once I get it, I could go ahead and apply it on all the data. So it has two advantages, right? One is definitely the person who is trying to clean the data has to do less work. He knows exactly what he's doing. And second is really, I think, you know, the subject matter expert or someone who knows about this data, they are very few, right? And their time is very costly. So we cannot actually show them 100,000 rows and says that, no, what, why don't you clean this data? So this is a way to really make almost like effective use of the people who know this data without actually compromising on the eventual quality of the data. And again, right, this example is just a exemplary example, right? Because everyone understands the male female thing. But if you think about, there is some very, very focused, right, let's say healthcare data, right? Common people would not even understand, right, what each column means and what are the values there and things like that. But if you go to a doctor and say that, hey, here is 100,000 rows, please correct it, it's going to throw you out. So this is one of our ways to make the data usable through, right, small sample selection and making effective use of SME efforts. All right. So now I think, like I said, right, the AI testing. AI testing is, like I said, a really big area, and these are a lot of steps in AI testing. We will not go over all these steps. I think I'm going to focus only on these two steps: data analysis and test data generation. So one of the important thing is the following, right? When we, if you look at something like a simple program and test case generation, there, by looking at the program or by looking at the variables and type of variables, we could get certain ideas about what kind of values are logical for this program, right? So if you have integer, you would think that, okay, right, any value from 0 to 65535 should be okay. It's a fair game. But that kind of thing don't work for AI testing, right? Because for AI testing, the model has learned certain behavior based on the training data. Now, if your test case does not mimic that kind of behavior, then of course the model is not going to perform well. But that particular test suite is also not a very, right, good one. It doesn't matter how the model does on that test suite because the test suite is badly constructed. So that's why I think these two stages, right, to say, how do we analyze the data and how do we use that analysis to generate realistic and plausible test data which mimics the training data is extremely important. And then there are other part to it to say that, someone says that, okay, right, here's my AI model, I want to test it for fairness. You need to generate a very, very different test suite for that versus if someone says that I want to test it for robustness. So that's a, right, extra dimension of complexity when it comes to testing AI applications. And of course, then there are a lot of the core systemic efforts to say, how do we manage the test cases? How do we store it? How do we continuously refine them and things like that? But let me explain a little bit. I think we spend 1 or 2 slides to explain why the test data generation is a very hard problem. So let's look at an example of text, right? So let's say we have a sentiment analysis model or a chatbot, and I want to generate test cases for that. The test cases should really mimic the training data and should also mimic some of the real life mistakes which people make when they interact with any text-based system. So for example, right, spelling mistakes. So it's easy to take a word and say, I'm going to introduce spelling mistakes in it, right? You can just remember it, edit any alphabet and say, here is the spelling mistake. But it's not a valid one, right? Because mostly when people type, they will usually make spelling mistakes, right, due to slip of the finger on the adjacent keyboard characters. So maybe, right, Bill will become BKLL because I is very close to, right, L. Or, right, you might miss a G from package and things like that. So how, again, right, these are two simple examples. And now, but the thing is, if I want to generate millions of such variations, it becomes very difficult. We require some good system to do it, right? Similarly, right, simple things like if you read, right, then the next one, right, from wow to wow, it looks exactly the same except that O is replaced by 0. So many times, when you look at the text, it looks fine, but it's not. Or many times, right, you, instead of happy, you put a, right, emoji of happy, right? When someone reads it, they could read it, but the text system will not know what happy to emoji of happy means. And then of course, right, you have these voice variation, right? That someone types in active voice, someone could type in passive voice. Many times it could just be right kind of exclamation marks, right? So someone says my credit card is not working, question mark. Someone could say my credit card is not working, exclamation mark. And even though for humans these are almost same, right? We read it, we understand, okay, the problem is that credit card is not working. But the AI model, maybe it paid too much attention to question mark when it was training, and it has learned a pattern that question mark means question and exclamation means feeling. And suddenly, everything goes wrong in real time. And sometimes, just the way people write English and just how proficient people are in English, some of the phrases, some of the words could be interchanged. So, and of course, right, adjective variance is another part, right? Someone says, I'm looking for a cheap plan. Someone says, I'm looking for a cheapest plan. And these could be interpreted differently if not tested properly. So again, right, so these are just like 5 dimensions, and there are more listed here. But the only reason to go over some of these was just to kind of impress upon you on the complexity of the test case generation for AI applications. If I were to test a simple application which says that, okay, right, take a sentence and convert everything from small cap to large cap, I could do any kind of test case generation, doesn't matter. But for AI models, I think we need to be really careful on how we generate these test suites so that any kind of testing makes sense. Okay, all right. So what are the kind of a different features we may want to look at when we generate test cases? So like I said, right, it has to be realistic. The data has to be, it has to preserve the properties of training data. It also needs to preserve some of the real world constraints. It should be plausible data. We cannot generate random data, right? And then of course, right, it needs to be effective. We don't want to generate 100 million test cases to find that 5 test cases which fail. It should cover overall model, right? That's the right kind of a first principle for testing. And then variety, right? Like I said, we do need to cater for different users defined specifications. So like I said, some user could come and say, I want to test my model for fairness, and we are going to generate a very different test suite for it. Someone could say, just I don't care about fairness, just make sure my model is accurate. We do differently. Someone could say that, I'm okay to compromise a little bit on accuracy, but please test if my model is not overly sensitive to certain small perturbations. We generate a different kind of test suite for them. So even though the end goal is still testing the same model, based on user requirements, the test suite could change. And then one of the very important thing is just like data to be explainable, model to be explainable. The the test suite and the places where the test suite fails, I think it will be very nice if the testing framework could provide some additional insights to say what is the common property of all that failed test cases, so that it gives a very focused recommendation to the data scientist so as to what he needs to improve to handle those test cases. And again, right, I think each one of these, right, even though I spend like 10 seconds, they are active area of research and could take like multiple years for us to kind of really solve these problems in a comprehensive fashion. All right. So with that, I think let me just look at the time once. Okay, we are good. With that, we move to the last part, which is how do you make the life cycle discoverable? What does it mean for all 3 stages? So let's look at it. So data, right? So what does it mean for data to be discoverable? I think what it means is that all our data should have very rich set of metadata associated, right? Because unless metadata is there, we will not be able to search that. The search needs to be really smart. The search cannot be just our keyword based matching. It needs to be more than that. And I think as we make our metadata richer and richer, there we might actually get into problem of abundance, because now for one data set you could have like 100 different kind of metadata. So then there should be a role specific metadata to say that, this part of the metadata is very useful for data scientists, but some other part of the metadata is only useful for security and governance officer. And how do we do that part? Then of course, right, to make the data discoverable, we need to make sure that it's indexed properly somewhere, all the metadata is stored, searchable. So for that, we often use some form of data catalog. And then of course, right, we do need certain kind of data profiling, which is visible on a nice interface to the user so that they could look at the data profile and say, yes, this is the data I want to use because it has all the characteristics which I need. So how do we make these kind of profiles for the data and that kind of elevate it to the user is a big task. Right? It might actually touch upon some of the more human-computer interaction areas, but nevertheless, it's a kind of important task to be done. I think training, we talked about it, about the model metadata. Just like on the data, we also need a purpose-based search. So if you look at the same data, people could have trained multiple models on it. How do we search the model which we want to use? For that, I think the idea is to use some kind of model catalog. And just like data profile docs, the corresponding area would be AI fact sheet. I'm going to talk a little bit more about AI fact sheet in coming slides. And then finally, on the deployment side, we definitely want to have a store which manages all these deployment scripts, do the runtime metrics catalog, right? So if you have this catalog right across from data to training to deployment, then you could actually see that someone could come into these three catalogs or maybe even a single catalog which feeds from all three and do a end-to-end search that, okay, this is my data which I want to use, which is the model which is already trained on this data. I get the model, which is a deployment script which will help me deploy this model. I get the script, and at least I have an initial pipeline ready by just using existing components, by just discovering existing components. So moving. So what is data discovery, right? So let's look at kind of a simple query, right? Which is a simple BI query. It's not even an AI query. Simple BI query to say, I need to understand my year-on-year revenue change by location, product, and account type. Simple query, people would. This is a very standard query which a lot of people are running. So, but why is it a difficult problem to solve? So let's look at some of these things, right? So first is you could have hundreds and thousands of tables in your data lake, which means selecting the right tables which could help you answer this query is a very difficult task, right? Then what does location mean? Is location same as geography? Is same as country? Same as zip code, state, city? What does it even mean, right? Then you could have hundreds of columns which have hundreds of tables which have a column named product. Which one do we want to use? The same column could have different users historically. So using historical data is important, but we still need to make sure that we allow for the different usage for same columns. Plus, I think, the data landscape is changing, right? New tables are getting created every day, columns are being dropped. So, right, what you learned yesterday may not be even valid today. So in a nutshell, right, the data discovery is a hard problem because there is abundance of data, but how do we sub-select the very few data resources which are right for the task at hand? And I think, all these things, both the things have to match, that we need to choose the right data sets which are relevant for the current tasks, and then only we will be able to do a good data discovery. So just to kind of articulate a little bit more, what do we need? So we need a right data lake or a data set which is properly tagged, right? Which means it has good metadata. There are automated tagging tools, but they do introduce certain kind of noises. But then at the same time, going and manually annotating each one of the data set is not possible, especially if you think about a big enterprise which would have legacy systems running for years and years. You can't go back and start to meta tag all of them. So So we need to do a lot of work here to make sure that the automated tagging is as close to manual tagging as possible. Then I think, like I said, right, how do we know that location could be same as country? In some context, it could be city, zip code. So we do need a semantic search. We also need a business context powered search, right? We need to be able to input, right, for maybe right ontologies. You could enter, right? You could include ontologies in your search to resolve some of these business constructs. Then, of course, right, you need to do data ranking because, like I said, right, a column search of name product could yield 100 documents, 100 database data sets. How do we rank them based on the task at hand? And one of the very important topics, which I think very many times we overlook, is governance constraints. So many times, you might be okay to run that query, but only be able on a partial data. So, for example, simply like geo constraints, right? So, sitting in India, we may not be right authorized to look at data which is right hosted, let's say, in Europe, and vice versa. So even though you are running a query to say I want to look at year-on-year data of all my products and all my customers, you may actually get only a partial view of the data which you're allowed to see. And of course, right, like even though I've talked about a lot of these stages and saying that we should have to automate it, but I think before we fully automate it, we need to have a human in the loop and feedback loop, and we need to make very effective use of our subject matter experts. So and finally, I think, like I said, I want to talk a little bit about fact sheets. So fact sheet is, in some senses, our kind of a reporting mechanism for AI applications. So I think if you look at like all around you, right? Like when you go and buy, let's say, some food item, you could look at the nutrition facts there, and you could decide if you want to buy that food item based on percentage carbohydrates, percentage fat, protein, whatever it is. Similarly, we go and buy our electronics equipment. We look at star rating and we know 5 is better than 4, even though we have absolutely no idea how that compressor of the refrigerator is made, but we know that 5 is better than 4 from an energy saving point of view. Right? Same thing goes for our right in mutual fund investments, your bonds, ratings, everything. However, I think things like these kind of nutrition facts or ratings are missing for AI applications. So what we have proposed is something we are calling fact sheets, which is to say that, you know what, I'm going to take an AI application or an AI model, and I'm going to note down all the facts of that particular model in a easy to understand readable format, so that people could just read that report before they even want to try out our AI model. So just like if you draw a parallel to kind of food, you pick 2 food items, you compare the nutrition labels, you pick one. Similarly, right, if there are 2 AI models claiming to do the same thing, let's say sentiment analysis, sentiment mining, can I just look at those fact sheets and then decide which model do I want to use? And the fact sheet template, it could be customized for each application, but it will have things like what are the data sets the model has been trained on, what were the testing results, is the model fair, is it explainable, has the model even been checked for bias, if it has checked for bias, what are the results, and things like that. So this really becomes the single piece of information about the model. People could look at it without even subscribing to the model and then decide what they want to do with this. So, and in some senses, right, if you look at the lot of things we talked about in the talk, right, around the governance, data governance, discoverability, a lot of these things, they could be folded into these fact sheets to say that, I'm going to read the fact sheet first and then decide what to do next. Okay. So again, this is a kind of, we have a journal paper and a paper on archive also, if anyone is interested. So now, again, right, one of the things I wanted to capture is what are the next step for all of us. And again, that I think I will talk to this slide with a disclaimer that this is based on the kind of work we are doing and the related search we have done. So some of the colors might be off, but on a broader note, I think this might be okay. So the green ones really show the areas where there has been a lot of focus recently. There is a lot of academic groups as well as industry labs working on it. Like how do we introduce fairness in models? How do we do explainability in models? There is a lot of work around it. But the corresponding work in data, right? Can you explain the data is somewhat lagging. But people have started to pay attention to it. So the orange ones are really where we have started seeing interest. People have started talking about it, and maybe soon they will turn to green. And the red ones are really where, as a community, we need to spend more efforts. We have to scale our efforts to really change that red to orange and eventually to green. So again, I think I just want to once again clarify, right? The red doesn't mean that zero efforts. Red actually means we need to do more than what we are doing for now, right? So, so again, right? One of the things we definitely want to kind of propose as a call for action is that as a community we need to really collectively look at the complete data and AI lifecycle and not just look at the modeling phase or the learning phase as the start and end of AI. We need to definitely look at data and deployments. And a lot of these things will be done through these kind of sessions, which we are doing today, where we educate each other, we do research, build, publish in these areas. So if any one of you is interested in collaboration, more discussions, looking at some of the work we have, doing a deep dive with us, please feel free to drop me a note at my email address. Then finally, I would like to thank IEEE Computer Society Bangalore chapter for hosting me today. Thank you. And we can open up for questions.
Yeah, thanks a lot, Sameep. Uh, Participants, if you have any questions, kindly post them in the chat window or kindly unmute yourself and ask the question. But make sure that you mute yourself back right after you ask the question. Yeah, do we have any questions? You can either post them in the chat window or you can ask them directly.
So thank you, Sameep. Just a quick question. So for example, there are a lot of issues around data privacy and governance, right? Because that directly affects AI and AI lifecycle as well. So how does your research on the trust and explainability of data are related to data privacy and governance? Anyway, they're related, or is it entirely
Yeah,
different? I think,
definitely.
yeah.
And that's what I said, right? When we do talk about data sharing, right?
Mm,
Some of these aspects come into picture, right? Like, see, one thing is, historically we have thought that, okay, if the data has any private information, I'm going to find it and redact it and then
mm,
start to share my data, right? But I think now people are realizing two parts, right? One is many times the redaction actually makes the whole data set useless.
mm,
Because now, you have redacted a column or you have redacted parts of the data, which now you can't do a learning on top of it. And
mhm,
second thing is, when you redact, right, there still could be certain roles which needs to see that data, which are authorized to see that data in their original format.
mhm, mhm.
So, so that becomes a really nice problem now because now you want to maintain one copy of the data, and based on right the requester, you want to in real time transform the data to present, right? So what we have done some work which we call it policy driven transformations. So which is to
Yeah.
say that if I have a database and there is a policy which says okay, Vishwas should not see this particular column in the raw format, but it is okay for Anand to see it. Then when Vishwas asks for the data, we are going to actually take that column, encrypt it, and send the data to Vishwas. When Anand logs in, he will see the raw data. So, so a lot of these kind of things are coming, and then once you encrypt the data, then the whole right, homomorphic encryption schemes comes into picture, so that people could still do computations on that data without breaching the privacy. So a lot of these things are related. We have done some work around privacy, SPI, PI identification, but
Okay.
much more than that to data sharing.
Sure. Thank you. So for example, this could also relate to different verticals, right? For example, in healthcare, the privacy of the data is paramount. And for example, say some of the IoT applications, if you're just measuring the temperature, I mean, it may not really matter much. So yeah, so I think that makes sense for different applications. So based on the vertical or the type of data that you're dealing with, I think your approach and even the explainability and the trust issue, they differ, right?
Exactly. Yes.
Okay, thank you. So audience, if you have
Yeah.
any more questions, please shoot them now.
Yep. The Q&A session is going on. Kindly post your questions in the chat window, or you can unmute yourself and ask the question. Participants, do you have any questions?
Yeah, I don't think anybody has questions. So once again, on behalf of IEEE Computer
Yeah.
Society, I would like to thank Sameep Mehta for this wonderful talk and taking us through the trust issues in data and AI lifecycle. And I request Anand to wind up the session with your Q&A specials.
Sure. Uh, Samip, so I have a few questions for you. They are not at all technical. I mean, they can be technical if you want to make it technical, but these are kind of like just common questions which I want to shoot at you, and you have to just uh, don't think too much, just answer it very quickly. It should be like rapid fire.
Okay.
Uh, so the first one is, how did you develop interest in the AI/ML field of study? I mean, how did you?
I think it's AI now. I think, but I think when I did my PhD, it was called data mining. At that time, data mining was like really the hot topic, new kid on the block. So just trying to find a topic, an area which was slightly sparse at that time. We jumped onto data mining. Data mining became machine learning. Machine learning became AI. So I wouldn't say that I consciously thought about it. Just I think the most friendliest advisor I could find there at Ohio State that shaped it to be data mining.
Yeah, well, we move to the next question. Participants, if you have any questions about the topics that we discussed, kindly post them in the chat window. So my second question is, what would be your suggestions for someone who likes to start their career or like to switch careers to AI or ML?
So I think, like I said, right, I think one of the things is when we switch to AI, it's definitely very, very important to learn the modeling techniques, the learning algorithms, take some deep learning courses, take a basic. But I think even before we take some deep learning courses, make sure we do a little bit more of linear algebra, a little bit of statistics, probability. Because now, everything is packaged, right? You can actually stand up a deep learning model without knowing too much about matrix multiplication also. But that's not the right way to do things. So I think instead of jumping directly and start saying that, here is my reinforcement learning algorithm, trying to play a game, it might be just better to kind of learn a little bit more about the boring topics like rate expected values and rate distributions and things like that. So that's what at least I would say, right? Because once you learn that, new things will come very easily to you.
Awesome. Yeah. Thanks a lot. So the next question is, okay. So I hope you are not spending all your time on AI and ML. So what do you do in your free time when you're not training some model or you're working on some project?
So I think we always again, right. I think still it will still be AI, but I think what we do is we do pick up some fun projects to work on the side. We are working on one right now, which I will not talk about it right now. But I think on a
Sure.
totally non screen time work, I think during the lockdown, just like everyone, right? All of us are ready to now go to MasterChef because we have cooked so much different kind of food. So that's one thing. I have started to in this lockdown. I learned how to solve Rubik's cube, which I wanted to do for some time, but did not get time. And now I'm trying to look for next activity which I can do at home and learn something, pick up more skills, non-technical skills.
Sure. Yeah, because you started doing Rubik's Cube, I guess it's a 3 by 3.
Right now it's a 3 by 3,
Okay,
and I have to get a 4 by 4 soon.
sure. Uh, yeah, so what is your favorite, be it a series or a movie or a book that features AI in which you liked a lot and you are like, okay, this is good.
Book, I
Something on the
think
top of the mind? Yep.
I really don't recall, right? Because on screen, right, we read so much about AI and all the time. So I think at least when I watch some movie and all, I like to be as far as away from AI as possible.
Okay.
So, right,
Yeah,
so
then in that case, what is your favorite movie? Just like common, something that is very nice.
I'm prepared for this, right? I don't know. I
Yeah,
think
sure.
this
No issues.
last movie, I think I don't know what the last movie I think I saw. I don't know which movie last I saw. Right, I watched the web series. Right, I saw Patal. I liked it a lot.
Okay,
Yeah.
nice. So, okay, this is kind of like twisted one. So, do you think AI will take over the world like the Terminator way?
But I think even if it does, it will be not in our lifetimes. So shouldn't worry too much about it. I think we are very far away from kind of what we call this broad AI. I think or general purpose AI. And we are still at narrow tasks, and that too also it's not like we have solved them completely. If you look at a lot of the tasks like image recognition, we still see
Mhm.
hundreds of papers coming on image recognition, even though we have been working as a there's a large part of AI community working on image recognition for quite some time now. So I think the broad AI or the general purpose AI will take a lot of time to come, and I still think right we will need to we don't have to worry about AI taking over the world, at least in our lifetimes.
Sure. Yeah. So, as a last question, is there a favorite memory of yours that is related to computers, maybe in your school time or a college time, which might have like sparked an interest in computer science?
So very frankly, I think the I don't call it fond memories, right? Because when I was in school, we used to have this 33.6 megabit thing modem at home. The speed
Yeah.
was very slow. So I think, but it's still right. I think in school days we used to do a lot of these, not school days, college days we used to do this C programming. So some of the C
Hmm.
projects we made, right, which were like now that I'm sure the college kids could do it like in hours based on the right Stack Overflow and other things. But I think we made some simulators, data simulators at that time, which at least was very kind of exciting for me and to really go and study some of these things more deeply.
Yep. I mean, that's what I have.